Okay, hopefully you had a little mental break. Now we're back into operations with vectors in R2 and R3. So we talked about position vectors and how they can be talked about in coordinate form, how they can be added. But what about a vector AB that's like just chilling out here in space? So what if we have A and B like that? Well, first of all, just realize that you can draw a related position vector OD. So OD would be here. Okay, so the position vector, remember, is the exact same magnitude as AB and in the same direction as AB, just translated so that its tail is at the origin. So how can we, if we know the coordinates of A and we know the coordinates of B, how can we write its related position vector OD? That's what we're solving in this section. So OA then is a vector here. Okay, so this is vector OA, and we'll define A as being y1. And then OB is the vector here. So we'll define B as being x2, y2. So how can we determine AB? Well, notice that AB is the resultant of opposite of OA plus B. Okay, so if we took a vector going this way, okay, so negative OA, and added it to OB, the resultant would be AB. So AB can be rewritten as negative OA plus OB, but really how we write it is OB minus OA. So this is what you'll be defining at. So if you have a vector from A to B, then you take the second one, the head, OB, and subtract OA. So this is x2 minus x1 and y2 minus y1 because you're taking B and subtracting A. Okay, so the magnitude of AB is the square root of this distance. Okay, so x2 minus x1 all squared plus y2 minus y1 all squared. So you might remember this from grade 10, this just being the distance formula. So visually I can show this. Really, it's just Pythagorean theorem, where this distance here is the change in the x values, so x2 minus x1, and this distance here is just the change in the y values. So this really is just Pythagorean theorem, where you're getting the magnitude of AB. So again, that's the distance formula from grade 10. So AB is equal to its position vector. Actually, sorry, this wasn't supposed to be D. This was supposed to be a P, position vector. So AB is equal to OP, which is just x2 minus x1 and y2 minus y1. So again, you're just taking the x values from the second coordinate and then subtracting the x values from the first, and similarly there. And that's because of the triangle law. Okay, there's a hint for you there. If they give it to you in unit vectors, just switch it to component form first. Okay, so here's a simple example. So given OA is 1, 3, and OB is 4, negative 2, determine AB and draw its position vector. So this is the same question, the same two vectors from above. We're just doing different things with it now. So let's try. So 1, 3, so there is OA. And then, well, B is 4, negative 2. So that's OB. So B is, we'll label these 4, -2, and A is 1, 3. So determine AB. So AB is the vector from A to B. So when it says AB, when they say determine AB, what you're actually doing is determining its position vector. Okay, so AB in this case is going to be the OB, right, minus OA. I didn't need the brackets there, sorry. So really it's going to be OB, so 4, -2, minus 1, 3. So you get 4 minus 1, -2 minus 3. So you get the coordinate 3, -5. So 1, 2, 3, and then down 5. So about here. So this is OP, where this is 3, -5. So OP is equal to AB. So when we talk about AB, when we find it, really it's the position vector of AB, but that's how it is determined in the coordinate plane because they are equivalent to each other. Okay, let's go on to another example where we're not drawing it. So given A, B, and C, calculate the magnitude of AB and then the magnitude of CA. So first, I'm going to just calculate the vector AB. So again, it's the coordinates of B, so 5 minus the x-coordinate of A. So 5 minus -3 is 5 plus 3, and then 22 minus 7. So that gives me the coordinate 8, 15. So then the magnitude of that coordinate is just the square root of 8 squared plus 15 squared, which is equal to 17 once you take that square root. Okay, so that's one way of doing it. It's just finding the coordinates of AB first and then doing the magnitude. Or you can do it all in one step using the long formula. So big square root. So remember, it's A coordinates minus C coordinates. So -3 minus 8 all squared plus 7 minus 18 all squared, and you get root 242, which is approximately 15.56 units long. Okay, calculate AB plus BC. So there's a few different ways of doing this. First, you could find AB and then you can find BC, then add them together. Or you can also realize that AB, sorry, I should do this, AB plus BC is just equal to the resultant vector AC. So really, we just need to find the magnitude of AC, which is the same thing as AB plus BC. So AC is equal to, so the coordinates of C, 8, minus the coordinates of A, so plus 3. And then 18 minus 7, so you get the coordinate 11, 11. So then the sorry, I'm running out of space here. The magnitude then of AC is root 242 as well when you put that in. Okay. So if you're going into R3, it's basically you're getting more of the same thing. Okay. So I'm going to kind of skip this to, well, no, we'll do this. Okay. I know this is just getting long for you guys. Okay, so if you have a vector, I'm just going to go through this a little bit quicker. If you have a vector OA, where this is x1, y1, z1, and then you have a vector OB, where this is x2, y2, z2, then the vector AB is there. it has a position vector that is equal, an equal vector here. That is just equal to x2 minus x1, y2 minus y1, z2 minus z1. So the reasoning is the same, it's just that we're adding that third coordinate, the z coordinate. Okay, similarly, if you look at the distance of something in 3 space, okay, so we're going to create a quick coordinate box here. So let's do, this is A, so A, 0, 0. Let's do a B here, 0, B, 0. And then complete this coordinate box down here. Make this point D. So this is A, B, 0. And we can create a vector OD along the bottom of the box. Okay, so then let's create C up here. So we can create the box. Hopefully you're getting used to doing this by now. It's pretty good, I'd say. So there is your vector P. So we'll draw OP from the origin out to there. Okay, so notice that OP, the magnitude of OP squared is equal to the magnitude of OD squared plus the magnitude of OC squared. Okay, and that's because DP here is an equal vector to OC. So OD, though, can be written as OA plus OB, okay, because OD is from the right triangle, OA plus OB. So really, the magnitude, right over here, the magnitude of OP can be written as a big square root of A squared plus B squared plus C squared. So if you want to know the magnitude of anything in 3 space, you can just take its 3 coordinates, square them, add them together, take the square root. Okay, so here's our big summary box there. So if you have A and B that are 2 points in 3 space, then AB can be written as, okay, x2 minus x1, y2 minus y1, z2 minus z1, and it's equivalent to its related position vector, OP. And the magnitude of OP is then big long square root, the x value, which is just x2 minus x1 all squared, plus the y value, which is just y2 minus y1 all squared, plus the z value, which is just z2 minus z1 all squared. Okay, so we'll do a quick example to just hopefully consolidate this. And if you're confused right now, I get it. When you actually do the work tomorrow, it should be more straightforward, and you'll see kind of how simple the formulas are. It's just deriving them that your brain can go kind of blank. So determine AB. So AB is just the vector from A to B. So we take our B minus our A. So 4 minus 7, comma, negative 7 minus negative 11, so plus 11, and then 25 minus 13. Okay, so that gives us negative 3, 4, 12. So this is our vector AB. Really, it's the position vector of AB. So it has its tail at the origin and its head at this coordinate, but it's an equal vector to AB. So then the magnitude of AB is, we just take the square root of negative 3 squared plus 4 squared plus 12 squared, and that gives us 13 when you do the math. Okay, lots to learn, I know, you guys. Really heavy note, especially because it was in 2 videos. Hopefully that kind of helped separate the concepts in your head. Thanks for watching. Hope you learned lots.